Okay, so today the lesson title says we have to talk about characteristics of quadratic functions. In reality, we've already started talking about some of the characteristics of quadratic functions. Let's go through a quick review of what we already know about quadratic functions. What can we count on with a quadratic function that we already know? It won't be in your reading here. It's going to be something, this is review, what we already know. What's one thing for you?
If it has a minimum, it opens up.
If it has a minimum, it opens up. No? Okay, you can finish that one. And if it has
a maximum, it opens down.
Okay. If it has a minimum, you can count on that the parabola will be opening up. If it has a maximum, you can count on that the parabola will be opening down. Okay, what's another characteristic we already know? Clara?
Does it always have to be in standard form?
Okay, it needs to be in standard form so that then we can make some other conclusions about it. What is standard form, by the way? Do you know it, Clara? Got that one memorized yet? Or know it? Standard form of a quadratic function. We're going to give Clara a chance if she wants to do it.
Standard form is y equals ax to the second plus bx plus c.
Yeah, standard form of a quadratic function is y equals ax squared plus bx plus c. And it's going to be important that, as Clara said, that we know how to put it in standard form because that a, b, and c are going to play really important roles. We already know that a plays an important role. So that's another characteristic. Michaela, was that the one you were going to offer up?
No, if it's negative, it's more likely that we pointing down.
What's it? A. If the A value is negative, then it's going to be opening down. If the A value is positive, it's going to be opening. Can the A value be 0?
No.
Why not? What happens?
Because then it will be linear.
Yeah, it'll be linear. Because A is what's getting multiplied times the x squared. If you take 0 times x squared, what do you get, Devontae?
0.
0. The x squareds are gone. It can't be quadratic anymore. Now it only has x's and maybe a constant. So it's a linear function now. So there's stuff we already know. There's a fair amount, and we're going to add to that today. Okay, so the first thing we're going to talk about is the 0 of a function. So it says here, we actually have 2 learning goals. I can find the zeros of a quadratic function from its graph. Now we're going to learn other ways to find the zeros of a function, but today we're going to learn how can I find the zeros of a function from its graph. So first of all, what is the 0 of a function? Okay, it's the x value that makes the function equal 0. So it's the x value that when you put it into your ax squared plus bx plus c, you better get out a 0 at the other end. So if you're subbing that x value into the function, it better get a y value of 0. Then it's considered a 0 of the function. Well, to find it on a graph, where would the points be? Clarion, could you put that here a second? Where would the points be that have a y value of 0 on a graph? Well, the origin has a y value of 0, yes. Are there any other points on the graph that have a y value of 0? Noah?
What if we do -5 or 0?
Okay, where is that point on the graph? Where is -5, 0?
X.
It's on the x-axis. Do you suppose every point on the x-axis has a y value of 0?
Yes.
Yeah, it does, doesn't it? So if the y value is 0, basically, if the y value needs to be 0 for a given x value, then we just need to look for the x-intercept. Where is it? Oh, I'm not spelling that well at all. Where is the parabola crossing the x-axis? And I'm going to put a little like this /s behind it because I'm guessing that sometimes in our homework for today, our parabolas cross the x-axis in more than one location. So here are the options that we have. For a quadratic function, there can be 1 0, 2 zeros, or no 0 at all. So let's take a look in our book and see what that looks like, okay? So on page 531, example 1, find the zeros of quadratic functions from graphs. In this example, it says find the zeros of each quadratic function from its graph, check your answer. So in A, y equals x squared minus x minus 2, they've already graphed that. And below the graph, it says the zeros appear to be negative 1 and 2. So remember I said the x value that makes the function equal 0, or in other words, it makes the y value be 0. So on this graph, is this parabola crossing the x-axis at negative 1? Graph A. Where's the other one it's crossing at, Corey? 2. So how many zeros does this one have? 2 zeros. It has 2 zeros. It's crossing the x-axis at 2 different x values, so it has 2 zeros. Notice what they did for the check problem below. What did they do?
They put in negative 1 and 2.
They put in negative 1 first, and then they simplified it and found out that, oh, guess what? We do get 0 for our y value. And then they put positive 2 in, the other place it crosses the x-axis at, and simplified it and discovered, you know what, that ends up being 0 also. So in other words, when we check them, we put them into the function and we see if we get 0 for y. Okay, let's look at graph B. This one is y equals negative 2x squared plus 4x minus 2. So why is it opening down again instead of up?
Because it
Has a negative a value. What's its a value? Negative 2. Okay, how about this one? How many places is it crossing the x-axis? One place. It's touching it right there, isn't it? It's, what's that called? What's that point called?
Vertex.
Yeah, we know that already too. We know that where it makes its turn is called the vertex. So this one only has 1 0, it appears, because it's only touching, it meets the x-axis at the vertex, and it doesn't cross it anywhere else. So the 0 for this one is what? What's the 0 for graph B? 1. How about graph C? How about graph C? Are there 1 0? 2 zeros?
none,
No zeros. Why?
because it's not crossing the x-axis.
It's never touching the x-axis. It's never crossing the x-axis. There's no x value that when you put it in, even though the domain is all real numbers, no matter what x value you choose from the number line, when you put it in, you will never get a y value of 0, because that parabola never gets down that low. It never gets to the x-axis. Okay, so we would say this one has no zeros. Well, if it has no zeros, can we check it? I mean, you don't have anything, you don't have an x value put in for the function to be able to check it. Okay, so we are going to do check it out problem at the bottom of the page here, 1a. So the directions say find the zeros of each quadratic function from its graph, check your answer. So, how about 1a, looking at that graph. Do you think there are any zeros?
No.
No zeros? Why not?
Because it's not crossing the x-axis.
Okay. It does not touch or cross the x-axis, therefore, there are no zeros. No zeros for this one. Now, this zeros thing is going to take on another role later in this chapter. So we need to connect right now to what does it mean right now, okay? Zeros mean, what are they? What are the x values that make the function equal 0? In other words, they have to come from the x-axis, because that's the only place where y is equal to 0. How about 1b? How many zeros does it have? Okay, so it's touching the x-axis at what? Everybody decide where it's touching the x-axis. What ordered pair?
3 0.
3 0? Okay, so let's fill that in here. The parabola is touching the x-axis at ordered pair 3 0. Is it touching it anywhere else?
No.
No? Okay, so it appears there's only how many zeros? 1 0. I'm going to use the word 1 because otherwise we might think the 0 is 1. There's only 1 0, and it is what? What is it? What is that 0? The x value
Three.
where it is crossing the x-axis, yeah. It's this right here. The x value that makes the function equal 0. So it is 3. So we're saying, all right, that the 0 for this one is 3. So now that means we need to check it out. When we sub it in to our function, what should we get for y? 0, yeah. Okay, 3 is going in for x in all the location where there's an x, just like when you were getting these ready to graph for today. You were subbing x values in. Well, we are not going to use our calculators and trust that they are just amazing, because guess what? Sometimes you may not put them in there correctly. So we're going to take this, like dissect it so that we can get it without that calculator. What's 3 squared? 9. Minus 18. Or we could change this to add the opposite, right? Plus a negative 6, which makes this plus a negative 18. And then plus 9. Now that it's all addition, does it matter what order we add them in? No. So we could say, you know what? If I want to add this 9 to this 9 at the end, because I'm good at that, I get what? 18. Positive 18. And now what relationship do those two numbers have to each other? They're opposites. And when you add opposites together, what do you get? 0. So guess what y does equal 0? Our 0 of 3 checks out. So this is just the check problem. This is our answer. The 0 for this quadratic function is 3. The x value that makes the function equal 0. Okay, let's make some conclusions here. When there's only one 0, what do you think we can conclude? It's the x value of the what? Well, look in your book at what we just did. Look at the example 1. And then we had 1b, we only got 1 0. Up in the example, it's the vertex. So when the vertex is on the x-axis, if that's where the vertex is on the x-axis, it's only going to be 1 0. Because it makes the turn there. It's not going to cross again. It stops there, touches, and turns. Okay? Whether it's opening up or it's opening it down, it does not matter. Okay? When there are 2 zeros, what can we count on? The parabola will cross the x-axis in
2 different places.
many different places. 2 different places. Even though I don't have it written on here, let's make it when there are no zeros, what happens again? We already have it up
It does
there.
not touch the x-axis
It
or
never
x.
touches the x-axis or crosses it, right? Okay. So any questions on finding the zeros of a function and being able to check them out? When's the only time we don't do a check problem?
When it doesn't touch.
Yeah, it doesn't touch the x-axis or cross it when there are no zeros, right? If there are no zeros, you don't have anything to plug in to make sure it'll make the equation equal 0. If there are 2 zeros, how many check problems do you have to do? 2, 1 for each of them. This one only had 1, so we only had to check 1, didn't we? But if there are 2 different zeros, we have to check both of them and make sure they both make the function equal 0. Okay, let's go to the back side for our other learning goal. I can find the axis of symmetry. Oh, we've already learned about the axis of symmetry. The axis of symmetry is the what?
It's the line that you can fold it.
Yeah, the imaginary line that can fold one part of the parabola on top of the other. Where do you suppose that imaginary line will always go through?
The
The
center.
vertex.
The center, which is the vertex, yeah. So a vertical line that divides the parabola into 2 symmetrical halves is called the axis of symmetry. This is kind of like its definition. It's a vertical line that divides the parabola into 2 symmetrical halves. One would fold on top of the other over this line. If we folded our paper on that line, that axis of symmetry, one part of the curve better fold over and lie on top of the other curve. It always passes through the vertex, you just informed me. Always has to pass through the vertex. The center, as Cody called it. here's the part that is so hard for us to get. If it's an imaginary line, it has an equation, right? Every line has an equation. Every line has an equation. The first graph that you had on the homework today was a line, was it not? And it came from an equation. Well, a vertical line has an equation also. Anybody just happen to remember what type of equation vertical lines have?
You're right.
It has an undefined slope, you're right. What's missing from the vertical line?
It's the,
It's been a while, I know, this is probably gonna be, so I want you to circle this though. And it's the equation that has no y's in it. X equals some number. X equals a number. And that number is going to be, where is it crossing the x-axis at? It's going to be the x value of the vertex, basically, is what it should end up being. There's no y's in the equation of a vertical line. Just like in the equation of a horizontal line, there are no x's. Okay, so we gotta remember I said somewhere plant that in that brain so it'll stay there. Okay, so we have three ways to determine the axis of symmetry. Page 532, let's flip in our books to page 532. Finding the axis of symmetry by using zeros. Okay, now I'm saying that there are actually other ways also, and so example 2 is by using the zeros, example 3 is by using the formula, and we're not going to do finding the vertex yet today, so we don't have to worry about example 4. So the first way we're going to go through is determine the x value of the vertex. So if you have a graph, you already can pick out the vertex. You can say, guess what? Here's the x value of that vertex. So in 2a, we have a graph. Cool. What's the vertex of that graph? Pardon, what was the first number you said? 2, 0? Negative 3, 0, I think. 2a. Negative 3, 0. The vertex from that graph is negative 3, 0. Everybody see that? That's where it's making its turn. We're going to check it out problem number 2a. Okay, sorry. We're going to check it out problem number 2a. Okay, well then, that means one of the ways that if we can tell what the vertex is, we get to do something this easy. If it's crossing through the vertex, what is the number that that we're going to set x equal to? No, the x value of the vertex. So our axis of symmetry is x equals negative 3. Every point on that line has an x value of negative 3. It doesn't change. It doesn't go left or right. It's going straight up and down. The only thing that's changing on that line are the y values. So basically we're saying the axis of symmetry's equation is x equals negative 3 because every point on that line has that x value. So this is our axis of symmetry, and we write it as an equation. We don't just say negative 3, we say x equals negative 3. Well, then we have, what happens if, we're going to do 2b, what happens if we really can't tell what the vertex is for sure? Can you tell in 2b what the vertex is for sure? Are you feeling really certain?
no.
You might think you are, right? You might think. Anybody want to predict what they think it might be? The vertex in 2b? Anybody want to predict what they think it might be? 1?
Or both.
1 and
1, 4 and a half? Is that what you said? Could be. You think it might possibly could be that. Ordered pair 1, 4 and a half. Okay, but we're not really for sure. And so what we're going to do is we're going to do they have the 2 zeros plotted though, don't they? Okay, so we're going to take the zeros and we're going to divide those by 2, because if we add them together and divide them by 2, we should find halfway between them, shouldn't we? And remember, there's some symmetry going on here.
Yep.
So if we can find the 2 zeros and add them together, divide by 2, we should be in the middle, shouldn't we? Okay, so
Negative 2 and 4.
negative 2 and positive 4. Everybody agree with that? That the zeros are negative 2 and positive 4? The x values of the points on the x-axis? Well, that adds up to what? 2, positive 2 or negative 2? Positive 2. Okay, so now we're going to take that positive 2, our sum of our zeros, and we're going to divide it by 2 to get it in half. Got lots of 2's going on in this, sorry. And 2 divided by 2 is 1. Well, sure enough, the x value of the vertex is 1, isn't it? X equals 1 is our axis of symmetry. We got a 1 saying halfway between the x value is 1. Remember, all the points in the line got to have that value, so it's x equals 1. And remember, these axes of symmetries go like this, don't they? They're dashed imaginary lines on the graph. You know that they're there, dividing it into 2 symmetric halves. Okay, now we're going to go to example 3, where it says finding the axis of symmetry by using a formula. In other words, there's no graph. So we have this formula. I want you to put a box around it or something. This is the formula you're going to use. X equals, remember it's an equation, axis of symmetry is an equation, x equals some number. We're going to get that number by taking negative b and dividing it by 2a. Okay, so we got to first then decide, just like we've been doing in the past, what's the a, b, and c value? Well, in this case, we only need the b, a, and b, so let's identify the a and b. What's the a value? 2, because it's in standard form already, right? And the b value is 1. So we're going to just put your negative sign out front, okay? It's really kind of out front of the formula. And then upstairs, put your b value. Downstairs, you have to take 2 times the a value, which our a value is 2. So x equals, let's just leave that negative sign out there for a little bit. 1 over what? 4. So really what this is saying is the opposite of 1/4. What is the opposite of 1/4? No. What's the opposite of 1/4 is? Negative 1/4. This is it right here then, isn't it? Now, the reason I say that is because we have to be careful. What if there's some negative signs in your numerator or your denominator also? We could have more than just that negative sign involved here. We could have other negative signs. So always simplify your fraction first, or your number first that you get from your b over your 2a. Get that simplified first. And 1 over 4 can't be simplified anymore. We just leave it 1/4. And then with that negative sign out front, say, what's the opposite of this? And it happens to be negative 1/4. So we can just leave it like that. From a graph, do you think we would have been able to pick that out? No, that would probably have been even, it wouldn't have fallen on a grid line anywhere. It would have been hard to tell. So that's why the formula will always save us. This is the method that will always help us out. If we have the equation, we can use this little formula to help us get the axis of symmetry. Okay, so let's put this behind it because I didn't put it anywhere in your notes. I don't want you to know what we found here. We found the axis of symmetry. X equals negative 1/4. Again, it's a vertical line that's cutting through the vertex. Okay. Dividing that parabola into 2 symmetric halves. So today your goal is to be able to find zeros and to be able to determine the axis of symmetry, the equation of the line called the axis of symmetry. Anybody have any questions? Hearing none, I assume you're ready to go to work at home.